PITFALLS Institute.
Today, decades after it was introduced, thousands of organizations of all types from all over the world use Six Sigma to improve their operations. In this lesson, you'll learn the factors that account for this amazing longevity and success. This lesson will provide an overview of Six Sigma, including where Six Sigma originated and why the originators decided to use Six Sigma in the first place. You'll also learn what makes Six Sigma so successful, how Six Sigma helps you make sense of huge amounts of information that come at you constantly, and the limitations of Six Sigma. Six Sigma creates institutional change at a rapid rate, and as a Six Sigma belt, you will be at the center of the change. You'll learn how to help your organization adjust to the rapid rate of change caused by Six Sigma.
There are three common answers to the question, what is Six Sigma? Six Sigma is a metric used to compare process variation to customer requirements. Statisticians use Six Sigma to measure the variability in a data set. You'll learn how to calculate sigma later in this course. Six Sigma measures the process variability by how many sigmas there are between the process mean and the nearest customer requirement. The goal of Six Sigma is a process with only 3.4 errors per million opportunities. Prior to Six Sigma, world-class performance allowed many thousands of errors per million opportunities. Six Sigma is also a philosophy that relentlessly pursues perfection in operations. Six Sigma is a methodology that provides a framework for applying proven principles, tools, and techniques. The technology used in Six Sigma was around long before Six Sigma came along. But Six Sigma put it to use in new and more effective ways. Six Sigma was originally invented by Motorola Corporation to address its quality problems. When a Japanese firm took over ownership of Motorola's Quasar factory in Chicago, they found the quality levels to be abysmal. A year later, they had drastically reduced defects. They did this without changing employees, equipment, suppliers, or designs. All they changed was the way the factory was managed. This was a lesson that many American businesses took to heart as they watched foreign competition steal their customers. Six Sigma was a response to lessons such as this. It was a survival response. Six Sigma came into existence in 1986 at Motorola. By 1988, Motorola won the first Malcolm Baldrige National Quality Award, and the rest of the world became aware of the existence of Six Sigma. Research has shown that quality levels are linked to costs. Costs rise exponentially as quality declines. This graphic shows that companies with quality at a 3 or 4 Sigma level spend between 15 and 25% of their sales dollars on cost of poor quality. Companies with quality levels near Six Sigma spend less than 5%. Since costs of poor quality are all non-value added, the benefits go straight to the bottom line. This is an important distinction between Six Sigma and the mindless cost-cutting programs that cut value instead of waste. Here's another way of looking at the relationship between Sigma levels and quality. The bottom axis shows the process Sigma level. The vertical axis shows the errors per million opportunities. Error rates drop dramatically as processes become more consistent. Since errors cost money, either in lost customer revenues or in replacement and repair costs, or both. This graph explains why the cost of poor quality and Sigma levels are so closely related. Six Sigma is a rigorous way to manage business processes. It is based on Aristotle's logic and Galileo's experimental method, combined with modern computer power. Six Sigma is all about identifying the root causes of outcomes. It proceeds step by step, testing assumptions as it goes, rather than accepting someone's intuition. The Six Sigma approach begins with an opportunity, either a problem or some potential benefit. This is a result that we either want to create or prevent. To do either, we must understand the cause of the result. We create hypotheses or theories about what the causes might be. The theories give us predictions. Then we collect data to see if our theories did a good job of predicting the results. We refine our theories until the predictions are good enough to form a basis for taking action. When this is the case, we take action to improve the process. The Six Sigma process is sometimes shown mathematically as a transfer function. Y equals f of x. Y is an effect. The x's are causes. The f is a transfer function that relates the two. After you've been doing Six Sigma for a while, you will learn something amazing. A lot of things that everyone is quite sure about will turn out to be false. At this point, you will find that you can never return to the old-fashioned hip-shot management methods. In Six Sigma, we abandon the idea that an organization can be run solely for the benefit of any one stakeholder group. It's not this group or that group. It's this group and that group. Six Sigma identifies the harmony of interests among the stakeholders and helps the leader balance outcomes so that every stakeholder group is satisfied. Six Sigma is not academic research. It is about doing things smarter. As a Six Sigma belt, you need to move deliberately through the 5 steps of define, measure, analyze, improve, and control, avoiding the temptation to get stuck in the analyze phase in a pointless quest for certainty. Get enough information to make an informed decision, then make the decision and move on. Six Sigma works well because the organizations doing Six Sigma create an infrastructure devoted to change. This includes the full-time change agents, black belts, part-time green belt change agents, sponsors, process owners, and champions. The leaders of Six Sigma organizations often change compensation and incentive packages to support change. Obviously, all of this costs a lot of money. To be sure that the investment pays off, Six Sigma organizations carefully monitor the benefits of Six Sigma. Finance and accounting usually plays the major role in setting this up. When you understand how cause and effect works, and how causes are usually interrelated, you'll see that a few big drivers dominate. Six Sigma helps the leaders focus on the critical few drivers responsible for the key outcomes. Six Sigma will provide you with the tools that help you identify and validate these drivers, and then drill down even further until you determine the root causes that affect the drivers. The leaders of Six Sigma organizations use Six Sigma strategically. They create dashboards that show metrics which are critical to the organization's success. Then use these dashboards to identify high-impact, long-term Six Sigma projects. The dashboards also show non-strategic metrics that are dangerously non-competitive. Short-term Six Sigma projects are undertaken to correct these situations. The balance of short and long-term needs is a hallmark of well-run Six Sigma organizations. You've probably heard of information overload. I/O is the result of having too much data to think about. I/O causes many employee problems, and these problems lead to delayed decisions and increased costs. The cause of I/O is the lack of a framework for making sense of the data. Six Sigma provides this framework. Each time you do a Six Sigma project, you will systematically build a model that links dozens of root causes to a few key drivers of a small number of important outcomes. Everyone in the organization will benefit from the deep understanding of cause and effect that you provide. Knowing which few buttons to push to make things happen will provide tremendous peace of mind to your leaders and managers. The costs and benefits of Six Sigma must be tracked. It isn't necessary to get to the penny accuracy, but you need enough information to prove that Six Sigma is worth what it costs. Six Sigma is not a panacea. It provides benefits whenever you are trying to improve an organizational process and where the path to process improvement is unclear. In other words, where the causes of improvement are unknown, Six Sigma can be used to help identify them.
I believe that some things don't lend themselves to being managed as a process, and Six Sigma shouldn't be used for these things. For example, in pure research, discoveries are made in ways that are not well understood, and they're unpredictable. If you try to make these processes predictable, there's a good chance you'll end up destroying the creative process.
Keep in mind that no organization can succeed solely by improving its processes. There are many other things that need to be done, such as staying close to the customer, understanding the competition, being creative, etc. As a Six Sigma belt, you will become an expert at using data to dethrone widely held myths. But don't be too quick to accept the data at face value. Think about why the data show what they show. For example, if data indicate that customers on hold for 1 hour are as satisfied as those whose calls are answered immediately, perhaps it's because the customers unhappy about holding have already hung up the phone and were not surveyed. In Six Sigma organizations, change is the norm. Changes are made before something happens that makes it obvious to everyone that change is needed. This is very different than a traditional organization, where change is usually avoided until absolutely necessary. Six Sigma organizations are constantly looking for things to change. Six Sigma organizations employ people whose job it is to make changes. Some of these change agents have day jobs, while others do it full-time. People generally react to the uncertainty that change brings about by being fearful. They will have many questions. Will I still have a job? Will I be able to do the new work? Will I receive training? Will my pay be affected? The only way to reassure people is with constant communication, and by consistently keeping all of your promises. Six Sigma uses a simple framework for pursuing improvement. First, an opportunity is defined. Next, we measure the process baseline and validate the measurement system. Then, we analyze the process to determine how we can improve it. Finally, we lock in the changes by devising and implementing effective control systems. Let's look at an example of DMAIC. Define the goals of the improvement activity. The leadership identified an opportunity, customer complaints. This is a why that is driven by assembly delays, which is driven by test failures, which is driven by solder defects. We could keep going, but the black belt decided to undertake a project to reduce customer complaints by reducing wave solder defects. Next, measure the existing system. The baseline wave solder defect rate was 5%. In Six Sigma, we don't use percent very often, but we translate the error rates to errors per million opportunities. 5% translates to 50,000 errors per million opportunities. This equates to a process sigma level of 3.1. The measurement system for this project was visual inspection, and the black belt confirmed that the inspector's classifications were reliable and accurate. Now analyze the system to identify ways to eliminate the gap between the current performance of the system or process and the desired goal. The team drilled down on solder defects and found the top 3 drivers. Additional analysis, using statistical and non-statistical methods, determined that maintenance problems, failure to follow procedures, and process settings were root causes. Now improve the system. This involved maintenance, training, and statistically designed experiments to determine optimum process settings. Pilot studies showed that the goal was exceeded and that the improvements in quality also improved other process measurements. Most important, the preliminary results showed that the process changes would greatly improve the top-level why that the project team was solving for. Finally, control the new system. The team changed the preventative maintenance schedule and the manufacturing planning. They also developed new process audit procedures, implemented statistical process controls on key process indicators, and changed the ways new employees were trained. That was a ground-level look at DMAIC. Here's a 10,000-foot perspective on the DMAIC framework. We start with an important opportunity, then define a project to pursue it. A defined project includes the business case, determination of the project's customer, the key outcomes for the opportunity this project will address, a statement of what is inside and outside the scope of the project, a description of the new process, product, or service the project will create, and a detailed timetable for the project. No definition is operational without a way to measure it. So that's our next step. What are the critical drivers? Do we have sufficient data to measure outcomes and drivers? Are the numbers trustworthy? What is the current state? Can we measure progress and success? Next, we analyze cause and effect. Our goal is to identify, very rigorously, the root causes driving the outcomes. We start by a close examination of the current process to see if there are any special causes of variation that can be eliminated. We build mathematical and computer models to determine what changes need to be made to meet our goals. Then we use our new cause and effect knowledge to improve the process by planning and implementing changes. Finally, we develop control systems that lock in the changes and maintain the improvements. The cycle is then repeated with the next project. Here's an excerpt from the Six Sigma Handbook that shows the different tools to consider during each phase of the DMAIC cycle. It is included as part of your reading assignment too. We are showing here so that you can get an idea that the DMAIC cycle is supported by a good set of technologies and tools that are going to help you as a black belt really pursue the project successfully. You have reached the end of this lesson.